So hello everyone, I'm back with another video where I'm solving the question on my actual board. I thought it would be great if I could do one question over here. That way maybe the teaching could be a little bit more effective, but I don't know. Let's try different ways out and let's see what's the best one for us. So as I've talked about in my previous videos, the goals while solving questions using the linear differential equation method is to make the coefficient of dy over dx or dx over dy as 1, which is the case. So the first criteria is fulfilled. The second one is to have only, if it is dy over here, then have terms containing only x on the right hand side. That's not the case. We have y cube over here as well. So our first aim should be to eliminate whatever that is. So we're going to divide both the sides with 1 over y cubed. So 1 over y cubed times dy over dx plus 1 over y squared times tan x is equal to sec x. So is this the standard form? No, because now the coefficient of dy over dx is not 1, even though the term containing y from here doesn't exist. So what we'll do now is we're going to suppose let 1 over y square be p. So if we do that, then now let's differentiate both the sides with respect to x. That way what we have is this, and after this implies that dp over dx is equal to minus 2 times y to the power minus 3, minus 2 minus 1, so minus 3, and therefore what we can write is minus 1 over 2 when this 2 moves to the left hand side times dp over dx is equal to 1 over y cubed. Why is this important? Why is this important, you might ask? I know you've noticed something that's not regular. So yeah, that was a mistake. I hope you know now what missed out. Since it is y, we have to first differentiate this term with respect to y, and then differentiate it with respect to x. So that was what is missing over here. So first of all, differentiate this with y, then differentiate y with respect to x. So yes, now what you might notice is this thing and this thing is the same. So we can replace the value of this as this. So, or minus 1 over 2 dp over dx is equal, there's a plus sign, plus 1 over y square is p, so plus p times tan x is equal to sec x. So now we have to remove this constant in order to make the coefficient of dp over dx as 1. So for that we have to multiply both the sides with minus 2. So after that what we get is dp over dx minus p times tan x. Is this the way? No, it's not the way. 2 is missing, yeah. And minus 2 sec x. Now let's try to see if this is the standard form. We changed it from dy over dx to dp over dx. That's totally fine. Yes, the coefficient is 1. There's no term containing p over here. Yes, and we've got 2 tan x, which can be p, comparable to p. So yes, this is the standard form. You can consider it to be the standard form. Now we have to find the integrating factor. I hope you know from my previous videos that integrating factor is this. And p over here is 2 tan x, the term except or besides p. So it is 2 tan x, so is equal to, first of all, I think it would be less confusing if we just find p dx. So there is minus 2 tan x dx, and the integration of tan x, I hope you know, is ln sec x. And if we are to use the property of logarithm over here, then this minus 2 can go as the property of, the power of sec x. So that what I'm saying is ln sec to the power minus 2x. This is one of the properties of logarithm. Are you able to see this? Yes, you are. I think one more step would be fine. So finally, we can write this as ln 1 over sec square x. Wait a minute, let me check. Yes, that's visible. So this is the integration of p. Now let's find the final integrating factor. Let's go over here. So integrating factor is equal to e to the power p dx, the integration of p dx. So e to the power ln 1 over sec, oh, some writing error, sec square x is equal to 1 over sec square x. So some of you might be wondering how this popped up, so I'll just give you an example. Let us say we have e to the power ln 2x. According to what I did here, this should be equal to 2x, isn't it? Yes, so let's prove how this happens. So let's assume this entire term to be y, and similarly we can say that L and y is equal to L and 2x. It's just one of the properties of logarithm where, you know, this thing comes down, and then if this is to go to the other side, then it would be log to the base e y. So that way you can just cancel each other out, and this means that 2x is equal to y. So, and this means that this entire thing is equal to 2x. So I hope you got an idea how we can write this. So this is the integrating factor. We have the standard form over here. So then let's just multiply this with the standard form, shall we? So or 1 over sec square x dp over dx minus 2p times 10x. Let's not waste a lot of time in this question as it's not very difficult. So this cancels this, and I've talked about using a product rule over here. So if you are to do 1 over sec x is cos x, that's what I've written here, no confusions over here. There may be some confusions over here, and I'll clear it out. If you are to open this in the form of product rule, then you'll exactly get this. Whatever is over here, you'll exactly get it. 1 over sec square x will probably be common from both the sides, so it will be like differentiating p with respect to x, the 1 over sec square x as it is, then plus differentiating this with respect to x, this will remain as it is. So you'll get this. If you don't believe me, you can just try it out. It's of no harm. Now let's send this dx over here and integrate both the sides. Let's be quick. Let's be quick. Yes, so I've already told that the effect of integration and derivative is just opposite in nature. So when they are coming together, they just cancel each other out. Yep. Is equal to minus 2 sine x plus c, and then therefore the original value of p is 1 over y square. 1 over sec square x can be written as cos square x plus 2 sine x minus c is equal to 0. So there you go. This is the final answer to this question, and I'll leave you with a fun fact. So I know many of the people who learn integration and derivative, they just memorize, you know. So the integration of cos x is sine x, so they have no idea how that popped up. Of course, you'll have to remember so that you can solve questions faster, but then there's a question of how this came. So how the derivative of sine is cos, that's for another time, but then let's assume that you know how this popped up. then let's send this dx over here just the way we sent it over there, and let's integrate both the sides like the way we did here. Yes, cancels each other's effect, is equal to sine x. So there you go, you can clearly see that this is this. If you just know that the derivative of sine x is cos x, then you can use this knowledge to find the value of integration of cos x or anything else if you just know the derivative or the differentiation. So this is just a fun fact. This is our final answer, and thank you for joining with me, and hope to see you in my next videos. Thank you.